Okay, so today you had to read those pages 32 and 33. Someone want to share some of the important vocab that they found in their reading? Orlando?
Linear relationship.
Linear relationship. That's a good one, right? That's the whole unit's about it.
Coefficient.
Coefficient. There's a new term for us, is a coefficient.
Coordinate.
Coordinates. Okay, not very new. X and Y, right? Coordinate plane. You don't have any?
Well, mine were.
Oh, okay.
Equation.
Equation.
Refer.
What was that one?
Refer.
Refer.
Like you refer back to the
Okay. Yeah.
line.
Y-intercept. Important math vocab word. We've been doing a lot of teaching around that. Any other mathematical vocab? Maya?
Ordered pair.
Ordered pair. Right? So you had coordinate. In an ordered pair would be like 1 and 3. That's an ordered pair. A coordinate is just one of them. Okay, yes. A variable. That was in there as well. Okay. So today, we're looking at, I can determine how the pattern of change appears. So, a pattern of change. What have we been describing the pattern of change as? We've used a number of different terms. What are some of the things that create a pattern of change?
Constant.
A constant, a rate.
An independent variable.
Ooh, those don't. It's the rate, the constant, unit rate. All three of those create a pattern of change. So, in some of our equations, we would have things like, what's the rate? 3. 3 is the rate. 3 is also the coefficient of x.
So it's like the opposite.
They are kind of the same thing. If you think about it, it makes sense. Because what am I going to do to x? I'm going to multiply it by 3. So that creates a pattern of change, right? So that's why coefficient is similar. It's basically a number that goes with a variable. And it creates a scale factor for that variable. I'm going to do by 4, by 5, by 3. So that's our coefficient. So this pattern of change, you guys are doing such a good job at recognizing it in graphs, tables, and equations. So that's kind of what we're going to continue today, is a little bit of that work. Retakes the next Tuesday and Wednesday. So make sure you've talked to me. I already have kids coming. Some are coming on Wednesday, some are coming on Tuesday. If you don't come in on either one of those times and you do need to do a retake, then it will be during your lunchtime on Wednesday, the long lunch. Okay, so make sure to schedule that with me. Any other questions? Okay, I have over here Axel, and over there Liam. Okay, please take out your homework. Okay. Axel, put that on. You get your sharing.
And I did what you did. What? Oh, okay. So, for A, yes. Question was, for each company is the relationship between the number of people and cause a linear relationship? Yes, because they both go up by rate.
I said yes because we're supposed to go.
B.
I explained it. Yeah.
B. Each company write an equation that represents the relationship between the cost and the number of people. What is the dependent variable? What is the independent variable?
Dependent variable.
You
have to explain your equation.
For rollaway skates, there's starts at 0, so there's no point intercept. The cost equals the rate times number of people, and then for wheelies, skates, and stuff, the cost equals 3 times number of people plus 100 because that's where they start. That's their starting price. And then the independent variable is the number of people, and the dependent variable is the cost.
I can copy it right now. And it has page numbers.
Yeah, I did pretty much the same thing except I labeled these. And on this one I did +0 to show like when I labeled it the wires. For that I did variables and the numbers. So for the variables of rollaway I did C equals R times P. And for wheelies I did C equals R times P plus 100.
Wait, it's the other way around. ID is the person and GP is the...
Oh, and the rate equals cost.
Plus the y intercept.
What the heck, Mother? If I want to hold it, it's gonna fall. I know.
It's not gonna fall.
Yes. See?
Poke is dead.
No.
It's not gonna fall. It's like the wall.
So,
Stack of wires.
Alright, I got the same stuff.
I had to.
How dare you? How dare you?
Yeah.
Top of the uppers. And they walked up.
Following me.
All right, guys. So today,
It's looking.
we are going to start. Axel here. Trying to get the turn.
Yeah.
Yeah, sometimes it gets confused and kind of. Come on, you can do it. You can do it. All right, so. Okay, so listen. Today, we are doing independent work to start. Streeter. We're doing independent work to start. So I'm going to give you about 8 minutes. And I'm going to be circulating, kind of checking our understanding to see where we're at. So this is, you're going to have questions, I know. Work through them independently. This is a productive struggle time where you get to use your mathematical approximations without seeking help to start. So I realized I got to build a little bit more of this into our routine. I was doing some reading last night, and so that's why I'm doing it. It's on page 34. It's 2.3, and we're starting off on A all. There is a paragraph at the top that you need to start off reading. Okay, and I will be circulating once I take attendance, and then I'll come around. Okay? It is independent. All right. Not right. You use the back of it.
Do we need the stuff on the front?
Not yet. Not yet. Not yet. On 2.3 this one. When I talk. Okay. Put you down for Monday.
Wait, I don't think it's It's just really worded. My week featuring 49 plus 1 for the t-shirt. Does that mean that you're $50 for the t-shirt?
No, it means they charge $49 right off the bat, and then after that, every T-shirt is only $1. So it's like like you have to set up stuff to print T-shirts.
Yeah.
So it's like the cost of like setting everything up. Okay, so it's like a one-time fee. It's like when you order Domino's or something. It's like they're like, oh, we'll deliver, and you could buy 20 pizzas, but they're gonna charge you $5 to deliver. But then you have to pay for all your pizzas too. So it's a little bit like that. Does that make sense?
Yeah. What's it called?
That's the $49.
No, right, you're 4.5.
Yeah, times how many t-shirts you buy.
Okay, I was wondering if that was 4 times 5.
No, it's 4.5 and then times n. So whatever n is, you got to multiply by that 4.5. Okay? Because that's the rate per shirt, right?
But we don't know how many people there are.
No, but you read the question, it kind of, sometimes it will give you how many people, sometimes it'll tell you how much money they have. Okay, so a variable, right? A variable is either the C or the N. So one of these depends on the other. So yeah, so that's okay. But so if I have like 20 people who need a shirt or a jersey, right? This is called my independent variable because this makes my cost. If I have 20 people, I'm going to pay $69 because it's $1 per shirt. If I have 100 people, I'm going to pay $120. So this is considered my independent variable right here. And that's considered my dependent variable. Because this depends on that, right? You understand that? That depending on how many people I have, that's how much I pay. So that's why this is called the dependent, and that's called the independent. You do not need to change it. Okay? I'm just telling you that. So just keep working. So I wanted you to know the difference. Okay? That's why I like when you write these down, so then I can see what you're thinking and I can help you out. No. Yeah, no, coefficient's always going to be multiplied because it's basically like a scale factor for n. So in that 49 plus n, there is a coefficient, you just can't see it. And it's a coefficient of, because each t-shirt costs $1, right? So why don't they put the 1 there? Well, they don't put the 1 in front of the n because it doesn't matter. Anything times 1 is, well, it's still whatever the number is, right? So if it's 8, 8 times 1, 8. So they don't put a 1 in front. But if it was $2 per shirt, that would be a 2n. Does that make sense? And that 2 is the coefficient. And awesome. Good question. Okay, so you have two equations, right? Okay, so do you know what the y-intercept for Mighty T-shirts is? 49. What's the y-intercept for no shrink? Oh, you're good. Okay, so that's basically, it's just writing it down. You can put y-intercept, this, y-intercept. And the coefficient, we talked about earlier, the coefficient is the rate. So what's the rate of no shrink? 4.5. Okay. What's the rate of Mighty T's? 1. There you go. That's what they want. Does that make sense?
Yeah.
Okay. And then you need to describe what the independent and dependent variable is. You guys are rocking on this. Hey. Any questions here? We're good? We'll have a little bit of time here in about 5 more minutes. We'll have you share your answers, compare answers, and then we'll get back to it. So the coefficient is your rate, right, for each one of these. So the rate's really easy to see on Notion. What's the rate here? Because anything times 1 just stays the same. So they don't put the 1 there, but you know there's a 1 there. Go check. Curious to see what you got. There's a 12, yeah. So you got, so this is going to be, if I put in 12 t-shirts here for C minor. Yep. I put it the 12 in for where? Would it go in for the C or for the N? What does that C mean, you think? Cost. And N means number. So it says for each company, what is the cost? So they want to know this for 12 t-shirts. So I substitute the 12 in for the N on each one. And that's going to tell me how much I pay. So if there's like 12 people on a Fortnite team, right? You guys are all going to buy. You guys are all going to buy shirts.
Wrong person to tell because I don't play Fortnite. So.
But if I was, so if you were on a team and there's 12 of you, each of you would need a shirt. It costs $49 to set up. I was, hey guys, plus $1,200. Because each t-shirt costs $1. Down here, t-shirts cost a different amount, right? T-shirts are $4.50, that's the rate. So I need to know what 450 times 12 t-shirts is. Does that make sense? That's it. That's it.
So, I just number that multiplies.
So a coefficient is a number that multiplies a variable. The rate, yeah, that's what a coefficient is. In our linear relationships, it's a rate. Are you talking to her? Actually, not to. Yeah? Okay, guys, I'd like you to take a moment to share, and this is where you literally can share your answers. But if you have some sort of disagreement or some misunderstanding, please dig into that. Be like, wait a minute, how did you get your answer? What process did you do? Okay, and if you still don't understand, keep asking questions. James, you got to keep working because you haven't. Okay? All right. So go ahead, share with the person across from you. I'm going to give you about 3-4 minutes. Okay? You guys, you two go. Because he's way behind you. You guys keep going. What is it? Okay. So the y-intercept. The y-intercept. Let's go back. The y-intercept is where it crosses. Go back, Jacob. I want you to, no, in your paper, go back to page 33. In your textbook. So the y-intercept is where it crosses the y-axis. This is the y-axis. The line crosses it here. Now, that y-intercept means something. Usually means where you start. Like if you're in a race and you're trying to raise money or anything like that, it's usually where you start. That y-intercept. So, in an equation, in an equation like this, it's what's added on. Or, see how it's added on to the t? It's not multiplied. If a number is being multiplied by a variable, it's called a coefficient. Okay? And it's a rate. If a number is being added onto a to a variable, that is what we usually call a y-intercept. Okay? The other thing the y-intercept is, Jacob, is that when your x is 0, look here, when your x is 0, that means it's right there, what's your y? Here it's 45, right? When x is 0, what's y? That's another way to think of the y-intercept. Is that when the x is 0, so does that help? Okay. And your coefficient is what you multiply. It's your rate. Keep going. Are you guys done over here, Sharon? Okay.
You just have to add your 2
Yeah.
You want to eat for you?
That one's hard.
Make a table, graph, there's an equation. Okay? Either in all those ways. I showed you yesterday something you could do, but that's probably
Oh, I kind of remember it, but I don't remember.
when you have a C and a C, right? And I know this cost has to be the same number as that other cost. Remember that?
Yeah, I remember.
I can take that equation because that number, which is C, since it's the same as the one below, that means this part of the equation is the same as that C. So I can take that equation down, and I can make this equation equal that equation. And then I have to do some pretty cool math here. I got to do some subtracting on both sides or dividing. It's 100%. Okay, back to independent work. Okay, back to independent work. Don't want to have to write the name down yet. Yeah. Yesterday was like this, and then today. Okay, you guys.
I'm not.
Do you have any questions? So the other way that you can think about this is this one. This 12 represents the number of t-shirts I'm going to buy. You know the equations.
Yeah.
So I could put the 12 in for my independent variable up here and get an answer.
Weird.
Yep, it is.
How that goes up by that much.
Yeah, but the reason why is, think about it. It's So. But yes, it is right too. Okay, guys, can you guys look up here for a second? Put your pencils down. So I'm just going to do a little teach at the end to kind of reinforce what we were learning today. And maybe, hopefully bring some clarity. So you literally can like flip your paper over to this, 2.3. You can close your book because we're going to work on this parallel problem. So, with the ski team, with the Cloud City ski team, Lulu's worn it a couple times at school. They have, haven't you? Your jacket?
I think I wore it once.
Once, okay. So they have like a uniform, and it's a jacket, okay? So the club has to pay for those jackets. So they have to put out what they call bids to get people to like figure out how much these jackets are going to cost. So this is a hypothetical. It's not real at all. But let's say they put out 2 bids, and they heard back from Salida Print and BV Print. Salida Print said they'll do the printing and the purchasing for $120 per uniform. So it's $120, which is pretty realistic for how much it costs, per uniform. So I know that this is my coefficient and that's my variable. I don't know how many uniforms they're going to buy yet. But Salida Print said, hey, we're going to charge you $90 to set it up. And that's how much it's going to cost. Okay, so it's going to be $120 per uniform, Riley, plus the $90. BD Print says, hey, we will charge you $140 per uniform, but no setup cost. None, zero. Eclair. So we have 2 equations. What I've already done is I've already drawn the lines for these 2. I have at 6 uniforms, it's going to cost $810 through Salida Print. 6 uniforms through BV Print is going to cost $840. On the flip side, if I buy 0 uniforms from BV Print, it costs $0. If I buy 0 uniforms and I tell Salida Print I'm going to, it's going to cost us $90 because they have to do all the setup costs. So you can see here which one is the cheaper one to go with at the beginning. BV. BV is cheaper, even though, if I look at the rates, who has a higher rate? BV. But it's cheaper because why? There's no setup cost. Perfect. So we know that BV has a steeper rate than Salida for these costs for these uniforms. But wait a minute. Why is it up here, BV's rate, even though I'm paying less here, all of a sudden I'm paying more up here? What happens? David?
They have a higher rate, so over time they'll cross. And
so even though here it's cheaper, right? And you can see, if I only buy 1, 2, 3 uniforms, it's still cheaper. 4 uniforms, boy, looks like they're pretty much the same, right? Probably costing right around the same at 4. And then after 4, BV becomes more expensive. And what David said is right. It's a higher rate. So over time, it will cross Salida's rate of 120. It will at some point. Knowing where that point is really, really matters. Okay? It really matters because then you can make decisions. If I buy 4 or less, I probably go with BV. If I buy 4 or more, I'm going with Salida because, and if I'm buying 20 uniforms, what's going to happen at 20? It's going to be a big difference. It's not going to be a little difference in cost. It will be a big difference in cost. So I'll save a lot of money if I buy a lot of uniforms. Here are our y-intercepts. These are our coefficients. So if Cloud City has 18 athletes, who are they going to go with? Salida. They'll go with Salida print in this case. And I think you guys have more than 18, don't you? How many? You have quite a few, don't you? Huh? You know how many athletes you guys have? A lot. Okay. We'll take it right around 18. All right, guys. But that's the idea around rates, because I had a couple of people like, boy, it doesn't make sense with the T-shirts. At first, it's like one company's cheaper. And then all of a sudden you're like, boom, they're way more expensive. Right? That has to do with the rate. You had 2 rates. What was one of the rates? $1 per. And what was the other rate? So think about it. On a graph, $1 is 1 for 1. So that's going to be right up the middle. Right? I go over 1, I go up 1. The other one is I go over 1, I go up 4.5. So that other one is going to look like this. But the 1 for 1 starts like here. And the other one starts at 0, 0, but it's like that. It's a way steeper rate. So it's going to cross, and then it's going to get way more expensive than the other one, really fast. So if you buy a lot of T-shirts, I would not be going with that line. That would be really silly. You'd pay a lot of extra money. Okay. Please put away that. Please get your warm-up and exit ticket out as well as your planner. You guys did a great job working today, too. Really proud of the questions you asked. Okay, proud of the independent work that you did. And I even heard during that conversations, a couple of really good conversations about exactly what I was talking about there. Okay, so today, homework over the weekend. We have 7 A, B, C, and D, page 42. Your exit ticket is this. You are going to take your warm-up and exit tickets, and you're going to switch with the person across from you. So you guys, Clara, you'll switch with Isaac. Okay? Jackie, you'll switch with Warren. Don't worry about it. They're not going to grade this one. Okay? And then David, why don't you switch with Maya, and Anthony, I'll take yours. Okay, you'll hand me yours and I'll grade yours. Okay, so you're going to switch and you're going to use the rubric, 16-point rubric, to grade theirs.
Is it the week before we go to homework?
No, it's this week. This week. And then one last thing, guys. I have, Isaac, you will need an exemplar. This is a 16-pointer. So you can use this to gauge how well they're doing.
Already have one.
You already have one? Okay. Okay. You already have one? Okay. You're going to want to, yep. Here's the exemplar. Here's the exemplar. I'll put yours right there. You got to switch. No. There. You grade hers. Exemplar, guys. You need exemplar. Whoops. That's not an exemplar. This is. You guys have exemplars over here?
Yep.
She's got one. You have one? Yep. Okay. There's yours, Ben. Use Nina's. That will give you a really good idea. What? Oh, exemplar. I'm out. Where'd they all go? Here's a couple. I got one. Put it right in the middle. Okay, Anthony, I'll take yours and I'll grade that, okay? Thank you, bud. Okay, put that in there.